And now you all will have to remind me, and I think this is fine anyway. I know we want to talk about 10, 11, and 12 because Michael had a question. But are there any of the questions before 10 and 11 and 12 that anybody has a question about? Because again, we normally won't have time to discuss every single question on a particular homework assignment, but any of them could show up on the exam. So at this point in time, again, when you get it assigned on Tuesday, you all should work through it and look at it, and then see, oh, is there one that I find troubling? Which is exactly what Michael did, so I commend him for that. So if you guys have questions on any of the other ones, not 10, 11, and 12, go ahead and put it in chat or something like that. Let's see. William Brady, you're here, right?
Yes, I'm here, Professor.
Yeah. Okay. So Michael says he doesn't know how to do 8. That's good. So William, I'm going to put you in charge of monitoring the chat because I'm going to close chat for a minute and I'm going to talk about 10, 11, and 12, and then we'll come back and we'll answer the questions that are in chat. Okay, William?
Sounds good.
Okay, great. Okay. So let's go ahead and Michael and let's see, Abigail, you're here this morning, right?
Yes, I am. Hi, Professor.
Hi. So why don't you and Michael take number 10, and then we'll give you guys just a few minutes, and then we'll come back and look for your answer. Okay. Okay. You okay? Okay, Michael, working on this version of 10?
Yeah, that's fine.
Okay. Right. Abigail.
Hey, Professor, I'm
Yeah.
not sure if this is just on my end, but I'm not able to see your screen.
Oh, okay. Wait a minute. Okay, how's this?
There we go. There we go.
Okay. Yeah. So I ended up accidentally reloading the page, so it changed the equation. But you heard Abigail explain her technique, right? Which was just to plug in the number here and take the difference between the two equations.
Yeah, I understand that. Apparently I don't understand what surplus is. So
okay. Yeah, okay. So let me go. So read the question carefully, right? How much total surplus is created by trading unit 10? The one we had before was by trading unit 5, right? And then let's go ahead and apply Abigail's technique. So this is pretty easy for us, right? So if we plug Q in here, this is 145 minus 50, so that should be 95, right? And on the PV equation, we have 5 plus 20 is 25. So 95 minus 25 should be 70, right? Which is consistent with what Abigail told us on the other version of the problem, right? So let's go ahead and I'll switch to the whiteboard, because while you guys were working on this, I was drawing this, okay? And so hopefully, Michael, you recognize the equations, right? This is our demand equation PB, and this is our supply equation PS. Technically, they're the inverse demand and inverse supply, but we won't go into that. And this is some specific level of Q, right? We have Q there. And so Q is equal to 10. Now, I know what you likely did, and I want to point out that it's a common misinterpretation of that particular question. And so are you with me, Michael?
Yeah.
So you calculated this whole area, right? Going from Q0 to Q is equal to 10.
Yeah.
Right. And what Abigail did is she just looked at the difference, which is the distance here between these two equations. And I guess I'll just highlight that in what's a good color? Maybe. So she just looked at this difference, right, Abigail? The difference in the height
Yeah.
of those two equations, right? Now, I wanna point out that this is an approximation of the following. Okay, so in a general sort of scenario, we have some amount of existing surplus. Okay, and then we're going from some existing amount of output to a new level of output. And the question really is, what's the change in our total surplus? And it would be this additional trapezoid orange area that I have highlighted here. Okay.
Okay.
And so the two equations that are really relevant are, so you start with TS0 at x0, and you go to TS1, which is TS0 plus the additional amount. But the real zinger is the what's probably pretty obvious, which is if you take TS1 and you subtract off TS0, by definition you just get the DTS, which is the change. It's like the derivative of the total surplus function, but the real difference here is that instead of being an instantaneous or infinitesimal change in total surplus, it's a finite difference. So that's the only difference, is there's, you know, a distance here between x0 and x1 that is not approaching 0, right? So that's how we would calculate the change in total surplus of going from x0 to x1. Okay. But it's sort of a convention to assume, and maybe this is a good way to illustrate it, and then I'll try to move it back. But to assume, Michael, that when we're talking about a specific unit, like we said, what is the total surplus associated with creating the 10th unit or the 5th unit, right? That x0 would be a 1 unit difference. So you would be going from x0, in the most recent examples, assume that x0 is equal to 9 units, and you're adding just 1 more unit, right? And so if we were going to be like super technically accurate about this, we would say this is TS1 minus TS0, which is our DTS. And then on the bottom, we would have, let me see if I can get it to do this for me. We would have DX or DQ, okay? Because here X is playing the role of Q. And then if it's a 1 unit change, right, DX is equal to X1 minus X0, which is exactly equal to 1, right? And so in this fraction, DTS DX, if it's a 1 unit change, it's just 1, right? So we don't need to actually denote it there. You see what I'm saying? Because that would just
Okay,
be a
so
one.
basically what the question was saying is that like how much like what is the change in total surplus?
Right. Yeah. And so it would be the change in the example that we did before that you and Abigail helped out with. A change of going from 4 to 5 is implicit in the question, right? But the assumption is that that change is really a small change in the total. You see how I'm moving the line here?
Okay, so why do we assume that then?
Well, I'll tell you in a minute, but I'm just saying the assumption is that it's a small change. Okay, so you see how I'm moving the line to make this really small?
Right?
Yeah, and so small in fact that just merely taking the difference between the height of the two functions is a good approximation. So that's a standard convention. And so, yeah, you're right, and Abigail is right in the sense that technically speaking, we should take that height of the function at 4 and calculate this base of the trapezoid, and then take the height of both functions at 5 and calculate this base of the trapezoid, and then take the height of the trapezoid, which is between x1 and x0, and make that equal to 1. And if you did that, if you measured that change in total surplus from going from 4 to 5 units or going from 9 to 10 units, you would end up with a number that was really close to just the difference between the height of the functions at x1, which in the two cases we're talking about is x is either equal to 5 or x is equal to 4. So again, it's a convention in economics that we approximate that area with just the difference between the height of the two functions, which is this.
Right, yeah. I mean I understand that, but what I meant was like how would you know that the question was referring to a change in surplus instead of just
Okay.
in surplus?
Well, yeah. Okay. So let's go ahead and stop this share and screen share and go here. And well, okay. So number one is you probably wouldn't know unless you practiced and we had this conversation and you watched a bunch of the videos that I've done where I talked about this stuff already. You know, like your knowledge from principles of economics is likely insufficient to answer this question, but we're not relying on principles knowledge, right? We're expanding our understanding of economic theory. That's why this section of the course is deceptively simple. A lot of people think, oh, you know, he's just talking about the stuff that we've already done before, but I would call this, you know, a rigorous review of demand and supply in the sense that you'll learn a lot of things that you didn't know before. But I think the language of the question, you know, it does convey the meaning, though we could disagree about language. The most important thing is that you understand, you know, the rationale for what's going on. But it says how much total surplus is created by trading the unit Q is equal to 10, right? So can you see, Michael, how it's not, it doesn't say by trading 10 units of the good, which would mean, you know, unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, and so on to unit 10. But rather, it's asking about, for this specific unit, how much total surplus is being created. So once we get there, then we have to ask the question, right? Well, then how do we measure it? And the only obvious way is to say, well, you must have started out at 9 and now you're going to 10. And so one answer is the area of that trapezoid. But again, by convention, and a lot of times, people do this in applied math disciplines, and that's what economics is they have conventions, and they pass these conventions on from generation to generation of economists. And basically the convention is that, well, we know we're going from 9 to 10, but rather than calculating the area of that trapezoid every single time, we're just going to assume that the difference between the height of the two functions is a good approximation. Now, you asked before, like why is that taken as being a good approximation? And
I understand the convention. Yeah, I was just asking or why I wasn't sure about was how would you tell that it was referring to a change in total surplus rather than the entire total surplus?
Well, yeah, it's just the language of the question, because it's saying by trading the unit Q is equal to 10. And you'd have to ask yourself, the question, well, how could I measure the total surplus attributed only to the 10th unit, right? Because clearly it's not the total surplus of the first, the second, the third, the fourth, and the fifth. You know what I mean?
Okay.
It can't be that. So it has to be something else. What else is it other than that trapezoid that I'd colored before in orange? And then we take an approximation of that. And it is a good question to ask, well, why is that a good approximation? And in practice, the idea is that it's very, very, here we have numbers that are supposed to be relatively simple, so we can calculate the theoretical ideas, the formulas from the theory by hand pretty quickly. But in practice, normally you're talking about like thousands or hundreds of thousands or millions of units of some random thing like soybeans or tomatoes or tons of steel. And the idea there is that what we call a marginal change, a small change from 100 billion tons of steel to 100 billion and one, is going to make those two lines for the trapezoid relative to the total so close together that we might as well just use the height as an approximation, the difference in the height. So anyway, I hope that helps. So let's see how we can do with number 11. And go ahead and
Michael has a question about number 13. He asks,
okay, Michael who?
Michael Barbie.
Oh, okay. Yeah, he had asked about number 8 too, right? So earlier in the chat. So let's go and let's just do number 11, and then we'll skip and look at those other ones really quickly, okay? Yeah, let's go ahead and stick with Michael Left and Abigail for number 11, okay? I'll give you guys just a minute. Okay. Michael, are you good? Michael left?
Yeah.
And Abigail?
Yeah.
Okay, so what did you get, Michael? Left.
894.
Okay, and what about you, Abigail?
I got the same thing.
Okay, good job. And yeah, anyway, all the explanation I gave you is the best one I can give you, Michael. It may not be entirely satisfying, but that's the whole truth. So, okay. So, William, you were saying there were some questions in chat, right?
Yes.
And do you want to handle them in order?
It looks like
Was it number
Michael.
8 and 13?
Michael Quintana asked about number 9, and then after that was Michael Barb asking about question 13.
Okay, so so I've got all these Michaels. So so Michael Quintana, you there?
Yeah, I'm here.
Okay, so let's do number 9. Okay, and let's see. I'll do Andres, you here? Andres Estrada, tell us. Okay. Okay, how about you?
That's not working.
Okay. What about, oh, his mic's not working? Did he
Yeah,
type that in chat?
in the chat.
That's okay. He can still work on it with us. So yeah, so we're doing number 9. So I'll highlight it and I'll give you guys just a minute. Okay, so Andres, you want to go ahead and type your answer? in the chat for us? Okay, he's still working on it. And what about Michael Quintana? How are you doing?
Well, I had trouble with this one, so I got like a really wonky number. I'm not sure if it's if it's correct. It's I got 1,877.
Okay, well, why don't you tell me how you did it?
Well, some fellow students recommended I take the average, but that still didn't come out. So I ended up plugging in Q for both of them, and then adding them together. That's the only thing I could think of that would probably make sense to add the total cost.
Okay, okay, let me show you something. Okay, can you see that?
All I see is the lithium page.
Oh, hold on, wait a minute. How about that?
Okay, yeah, I can see it now.
Okay. So does that make sense?
Kind of.
Kind of. Well, you see, it's a trapezoid, right?
Yeah.
And in our example, we have two different levels of Q. One is 3, and the other one was 26, right? And then we would have the height of the function at each of those points, which would measure the bases of the trapezoid, and then the difference between you know, 3 and 6 would be the measure of the height of the trapezoid, or the distance between the bases, right? So you got kind of like part of the way there. The point that I want to make, and again, honestly, you wouldn't know this unless you watch, you know, the videos in detail and, you know, take notes. But our supply curve is actually the marginal social cost function. Okay, and I'm just going to abbreviate that as the marginal cost function. And there's a relationship between the marginal cost and the total cost, and that is the total cost, and this would be the total social cost. It really kind of depends upon, you know, the interpretation. Again, you'll have to listen to the videos. We could distinguish and say, oh, it's the private cost of the suppliers, but we assume in competition that those are the only costs that society bears, is the cost of the people producing the good. Again, as opposed to, remember, in our last lecture, we talked a little bit about externalities, and externalities are third-party impacts. So for example, if this was an electricity plant spewing smoke into the air and, you know, killing people who live nearby with air pollution, then those people have costs too, right? But we assume under competition that there are no significant externalities, and so those other third-party costs are zero. Anyway, big picture is that the area below the supply curve is the total cost of producing any given number of units of the good. So you have to use the trapezoid formula, right? And so do you think you can do that now? Are you good?
Yeah, I got it now.
Okay.
Andres, got the answer 21,585.5.
Okay, so let's go ahead and Andres, did he do it this way?
He says yes.
Okay, so let's go ahead and we'll move back to Ignithium practice. And you want to tell me what his answer was? Well, let's just do the hints.
Yeah, that was his answer.
Okay, good job, Andres. So that's how we'd calculate number 9. Now we had another question you said from Michael Barbie on number 13, right?
Yeah.
Okay, so Michael Barbie, you there?
I'm here, Professor.
Yeah. So Michael, what was your question? Because it says how much total surplus is created by the market.
So before the other questions give a value for Q, I'm wondering if we're to assume here the total surplus between the equilibrium and 0 units, or
Yeah, because normally when they ask the question like this, it would be the total surplus created by the market, meaning the market at market equilibrium, right?
Okay, understood. That's all I needed to know with question 13.
Yeah, you just have to calculate the market equilibrium first, and then take the difference of the area between demand and supply. It'll be really nice. It should be a nice little triangle. So it should be pretty easy. Okay, so we're starting to run short on time. Did we have more questions, William, in the chat?
That's everything.
Okay, so I'll ask once and you know, for all, and obviously you know, you'll find this stuff discussed in detail on the videos that are posted. But does anybody have any final questions? Is there something they're kind of unclear about? No, and I'll look in the chat myself. Oh, so Benjamin Garcia said he wanted to see the answer for 12. Okay, Benjamin, does that make sense to you?
Yeah, I was working on like my Ignithium homework that I have because my numbers are different, and I keep,
Yeah.
and like my answer is just about 3 off, because what I'm doing was I found the total surplus by the first unit, and then
Yeah.
and then like how you said, like the little trapezoid that's gonna form when you add the second unit, and my answer is just about like three digits off, not 3 digits, but the answer on mine is 53, and I keep coming up with 56. So I wanted to try this problem to see if it was me or. So
Yeah. Well. Again, I mean, I'm assuming that Ignithium is being consistent here. So for us, in this question, right, for the second unit, if we did the approximation that we talked about, then it would be 924 minus 2, which is 922, right? Minus 26 plus 3 times 2, so that's 26 plus 6, which is 32, minus 32, and you get 890. Do you see?
Yeah, I didn't plug it in. I tried to do it like a graph, just to look at it like the graph and find the area that way.
Yeah, and like I pointed out, your thought process is fine.
Mm-hmm.
It's just that there's this convention in economics that when we're talking about the change of just 1 unit, we normally just take the difference in the height. And if you think about it, and you know, you could, that trapezoid, when you take the height of the trapezoid is the difference between the 2 bases, right?
Mhm.
And when it's 1 unit, that's always 1, right? And so if we take the difference between, and I'll show you, okay, new share whiteboard. Okay.
Yeah, I just plugged the numbers in and I was able to get the correct answer. So I think it was how you said with the.
Yeah, it's that they're using the approximation
Mhm.
for this trapezoid, and you know, if we take the difference in the height, if you really think about what we're doing is on this, and you know, honestly, this is probably like maybe boring to lots of people, but I think it's really kind of cool. I like, you know, like understanding like what's going on here. Okay, so what we're really doing is we have a trapezoid here, right? That's our DTS trapezoid. I'm going to try to draw it nicely, and I'm just drawing it on the side over here, right? And we would normally take the area of that, and the distance between the bases here is by definition it's going to be 1 because we're talking about 1 unit. Can you see that?
Yes.
But when we just take the height, which is the distance of one of the bases here, and we use it for the approximation, right? We're actually saying, okay, we're not going to treat this as a trapezoid. We're going to treat it as the area of a rectangle, right? So it's like we're treating this as the area of a rectangle instead. And obviously the do you see what I'm saying? Because
Yeah.
this would just be length times width, and the width is 1, so it's just length is the
Yeah.
area. And then you might ask yourself, and it's a good question, you're like, well, when is this approximation like good enough? And the answer to that question is, well, it's good enough when the number of units is relatively large, and we're talking about a small change in total surplus. So anyway, that's what we do. And you know, these types of questions are really good ones if you understand, you know, the difference between the convention and when it's appropriate. Because I'll tell you what, every once in a while you run into a situation where you're calculating the change in total surplus, and the approximation for a 1 unit change being like a small addition is wrong, and that'll pop right out to you. And so like the best example I like to use is when you think about really, really big pieces of output, think about like aircraft carriers. How many aircraft carriers do you think the United States government has? Anybody want to Google it?
I think it was like 11, if I remember correctly.
Yeah. And so if you add 1 more, that's a pretty big change, right? It's a, yeah. Or if you think about like things like space shuttles, or you know, something like, you know, like a huge undertaking, then you could go like, well, yeah, a 1 unit change isn't really a small thing. We could introduce a lot of error by using this approximation. But if you're talking again about, you know, hundreds of millions of tons of tomatoes, and you add a few more tomatoes or another ton of tomatoes, then yeah, I mean, the error you're introducing by using the approximation is probably relatively small. So it's at the end of the day, you end up finding, especially in like applied math disciplines, that there are practical matters of judgment that come into play. It's not all just about using math formulas. It's kind of using them in a smart or an intelligent or an informed way. Anyway, but for right now, all you have to do is remember that that's our convention, is the difference between the height. That's our additional surplus created. Okay, so there was still one more question about number 8. So who asked the question about number 8? Was it Michael Barbie?
Yeah, it was me.
Okay. Yeah. So what was your question about this one?
How do you do it?
How do you do it? Well, I'll tell you.
Yeah.
So let's go back here. Remember our picture for we drew one for total cost, right? As the area
Yep.
below. And so we know that we're gonna look at an area, right? And so go back. Okay. So the total cost of producing 3 units, right? So that's not producing the 3rd unit or producing unit 3. It's 3 whole units, right? So that would just be the area underneath the supply curve from 0 to 3, right?
Oh, okay. So it's area, not price point on the line.
Well, yeah. I mean, okay. So again, let's go back here. So you remember the equation for me. You write it down. Okay. It's 82 plus 5Q, right? So we go back to the whiteboard, and so actually this is good for us because we'll just use this area over here. I'll put it in purple because it's for 0 to 3 units, right? Our other question was from 3 to 26. But this is from 0 to 3. So you see the purple highlighted area?
Yes.
Okay. So at 0, the height is going to be 82, right? So that's one of our bases. And at 3, it's 82 plus 5Q. Was that right?
Yeah,
5Q. So 3 times 5 is 15 plus 82 should give us 97, right? So then we just apply the formula, which is the area for a trapezoid. So I'll put trap is equal to 82 plus 97 divided by 2. And that's the average of the bases times the height, right? You have your calculator?
Yeah, I do.
Okay, so hit me up. Tell us what you got.
268.5.
268.5. Okay, so
Yeah, my mistake was that I was just trying to get the price on the line at quantity 8 instead of the total cost. So yeah, I see what the issue.
268.5. Woo, you got it. So again, I'm pretty sure, because you guys have prior recordings and things like that. Again, I'm not gonna pull any punches. I'll tell you, I know this class is a lot of work, and it's a lot more work than most other classes. I don't apologize for that, only because for most of you, this is your major, and there are a lot of people. If you would ask Dr. Brown and Dr. Kerr and Dr. Nguyen, or any of the people in our department, what's the most important foundational course that you take in your undergraduate career here as an econ major? And almost everybody will tell you intermediate micro. If they don't, and most of us, depending upon people's specialties and whatever, most of us have taught it at some point. And everybody knows that it's a lot of work for you all. So if you haven't already started to like really dig in, yeah, dig. I'll help, but it's be warned that even with my help, you're going to need a lot of time on your own to go through the material. It's not going to be it's not like reading Harry Potter. It's going to be commitment. Okay. Are there any other questions? Okay.
I have a question, Dr. Hunter, not about
Okay.
the
Okay, so let me
necessarily.
then